Greetings friends, I am Stephen Edholm from SkillCult.com. Today's video is basically a follow-up on a video I did about splitting a big oak log into staves like this so that they could be further processed and seasoned into staves like this to use for axe handles and whatever other kind of things. So today's video is basically going through processing a couple of these, and that'll provide us talking points about wood seasoning and wood shrinkage and also hewing tips. So I've been trying to do this video for months. I tried to do it about 4 or 5 times, at least 4 times, so maybe the 5th or 6th time is the charm. Let's hope so. And this is a problem for 2 reasons. One is that these big chunks of wood, if they start drying out too much or dry out too fast, they could crack, and once the wood cracks, that's it, right? It's cracked forever. It doesn't, fix itself. The other problem is in this climate, I know this from experience, we have a beetle called the death watch beetle. At least I think that's the one that I'm seeing everywhere, is the death watch beetle, which basically just means they're waiting around for trees to die, and when the tree dies, they're like, zoom, move in and start eating the tree. There's a lot of them around right now because we have so many trees dying from this, sudden oak death disease that's killing these trees, that there's just a large population, I think, of those beetles around. So I'm hoping that they have not found these staves that have been sitting over here under a tarp. So what I did with these is I dipped the ends in paint. That's to keep the ends from drying out too fast, and I'll explain why in a second. And I left the bark on most of them, and I left this rotten punky wood on the inside right here on most of them. And then I put them under this tarp, and occasionally I've sprayed them with water on and off. And regardless of that, it's summer in California. It hasn't been a very hot summer at all, actually. It is still hot and dry, and they have dried out some, but I think the ones that have the bark on and have this on are still doing pretty good, and I'll explain more about that in just a minute. Before I get started on any actual hewing, it's important to go over some basic concepts of seasoning wood and how wood shrinks and dries and how to keep it from cracking and stuff like that. Right away when I got these, I processed a couple of them just because I had, a minute one evening or something. I dipped the ends in paint, and I set them out here on the ground. The ground was still wet. It's still springtime. It was actually like kind of rainy and drizzly. I put them out here on the ground, and then I've kind of just left them there for a few days. And even though the ends were dipped, they didn't crack, but the body, like this part right here, cracked really bad actually, just because they were there for a few days and the sun came out. It wasn't hot. It was just like a little bit windy and a little bit warmer and a little bit drier. Now this wood in particular, it cracks pretty easy, so you have to take a special care. Like other woods, they just vary. Like some woods will crack more, some less. I mean, individual trees vary. But that just illustrates how careful you have to be sometimes with this wood. And I'm going to tell you why these staves in particular are prone to cracking because of the way that they're cut. But my point is, you just can't approach this haphazardly and expect to always get good results. Sometimes you will. Sometimes you can cut out a piece of wood, split it out, lay it on the ground, and it's going to season without any cracks, including no cracks on the end. I have some maple that's been sitting out here curing, and it's way less prone to cracking. Like there's large chunks and they just have small surface cracks in the end and no cracks across the, the body or anything like that. But, know your woods. I know my woods here that I use, and I've used this wood a lot, and I know it's very prone to cracking, that you have to take great care. Okay, so fast forward, I came out another time and I made a few more. I made like 2 or 3 more, and this time I was like, okay, I need to do something more just in case. So I dipped the ends in paint, and I had a bucket of lard. Okay, lard isn't the first fat I would choose to coat a piece of wood to prevent it from cracking, because it has a tendency, it's a little bit more of a liquid fat than say like beef fat, sheep fat, goat fat, deer fat, which are all tallows. And so a lot of it sinks into the wood, but this is coated with it, and you can see there's like a white looking thing here. That's the fatty acids in the lard that are more saturated and less liquid at room temperature. And so what happened is the more liquid fats kind of soaked into the wood or dripped off. We left this kind of surface coating on here. So I did several of those. I set them out here in the shade. Again, it wasn't particularly hot. I thought, okay, well, these will probably be okay. Came back, big cracks all over the place. 2 batches. Okay, probably 3 or 4 good, larger handle blanks like this. Now what's interesting is that those cracks are no longer visible, most of them, and I'm going to talk about that in a minute, but that doesn't mean, you could say that they healed. Looking at them, yeah, they healed, but of course they're still there. The wood doesn't just like literally glue itself back together. So again, just trying to illustrate that, you can try it if you want to just find out what happens and you don't know yet. And of course this is going to vary tremendously. Like my climate is fairly dry here, and if you live on the East Coast and it's always humid every day, everything's going to dry slower, but it's warm enough that there's still moisture moving, right? So that's a little bit safer. So it just depends on where you live in your situation in your woods. But let's talk about seasoning in general. I'm going to draw some diagrams on the chalkboard here, and we're going to dig in just to like a medium level. I don't want to go too deep because that's not really what this video is about, and it deserves its own long video or two. Okay, here we have the end of a log. Now, wood shrinks more in this direction than it does in this direction. So in here, say, this loses a certain amount of moisture, this is going to shrink less, that's going to shrink more. If you have the end of a log like this with the center still in it, when this shrinks, it can't compress because this isn't shrinking as rapidly and this doesn't really move. This core is kind of static. A lot of tension develops here. So then what happens is eventually a weak spot will just split open like that and you'll get a big crack. As the wood is shrinking, like it's trying to shrink inward, it kind of fights against itself because this core is still static. Now that's made worse by the fact that this core is drying slower than the rest of the wood, right? From one of these cut surfaces out into the air, and then it has to be slowly replaced by moisture that's deeper inside the wood, and that only travels so fast. It doesn't travel very fast. It does travel very fast out the ends because the tree is this is like the capillary system of the tree, or the fiber of the tree, and how water travels in the tree naturally. So if I cut a log off like this, immediately moisture is going to start leaving really quick, and that's why I dipped the ends of these right away as soon as they were cut. So that makes this cracking even worse and even more likely, but a lot of it has to do with the wood trying to shrink around this static core here of the center. So by eliminating the center of the tree, like even if we just split this in half like that, that will actually help a lot, because now as this is trying to shrink, I don't know what the best way to draw that is, maybe like this, as this is trying to shrink, this all can move like that. Right? Things can move around, but before it was always pulling against this whole outer ring. So that helps right away, is to just get rid of the center of the tree. But another thing you could figure out from what I've already said would really help is to dry the wood at an even rate. So uneven shrinkage equals cracking, right? If there's uneven shrinkage of the whole piece of wood, if the outside of the wood, all of this, say out here, let's say we're taking this half, like all of this on the outside is drying faster than the inside, then the inside's going to stay big while the outside is trying to shrink. Therefore, you develop stress, and sometimes, there's always stress in drying wood, but sometimes that stress is large enough, or the wood is weak enough that a crack will open up, and that's how checking occurs. So drying pieces more evenly, which essentially means drying them more slowly, usually, can make all the difference in whether the piece cracks or not. So what happened with these is that they dried too rapidly. The core of the wood, this stuff in here, stayed fat and full of water, while the outside was trying to shrink away, and then these cracks opened. Now as this shrunk back down in the middle, those cracks basically closed back up to the point where you can see very few of them, and they were big, wide open cracks before. Again, those cracks are still there. I may actually go ahead and use some of these, because those longitudinal cracks like that, they only weaken wood so much, but they do weaken wood, and if they're deep and big, they could cause a problem in the future. It's just kind of a gamble. But most of you have probably used a lot of tool handles that have longitudinal cracks, and they can work just fine for long periods of time, including even axe handles. Okay, so another factor to consider here is how the billet is oriented in the log. So what we did here is we split out these kind of wedges, basically. In our case, this whole part of the center of the tree is rotten. We only had kind of this outside rind to work with. Let's draw in a few more growth rings here. And in this case, we still have some of the rotten wood is still on here. So the way that I oriented these billets is that I want to take off some of this sapwood right here, all of this rotten wood here, and I'm going to end up with a billet that looks like this. Now that billet grain orientation gives me what I want, since the axe handle that's in there is going to be oriented like this, and so the grain's going to run, the grain rings are going to run this way, which is what I want. And I could also say carve out a billet and dry it that looks more like this. So we have this rectangle versus this type of rectangle. I have this right here. Because wood shrinks more in this direction, this big wide face right here is more prone to cracking. If I were to orient this the other way, say this theoretically was oriented this way, and that's more like quarter sawn or rift sawn, it's called. I mean, this technically would be more like a rift sawn piece. This is going to shrink more in this direction, in the narrow dimension. The wood's going to shrink more in this dimension than it is in this dimension, you know, per inch. And so that's going to be less likely to crack. So I basically set myself up here with these pieces of wood for them to crack more easily. Now, the reason that these pieces under the tarp haven't cracked really bad is because of this grain orientation here. The most prone to cracking part is this outside face right here. So if I were to saw out a board like this, a bunch of boards, those would be called plain sawn or face sawn boards, and those are much more likely to crack and cup and warp and all kinds of stuff. They're much less dimensionally stable than boards sawn out in this direction, taking out, say, thin boards like this. This would be rip sawing like this if you took out boards that way. Point being that when they're sawn this way, I have to be that little bit extra careful, especially again with this wood. This wood also has these really large ends here where the rays come through that are just kind of spongy and prone to opening up. So by way of demonstration, I chopped this green piece of tan oak into something like a square shape with two basic grain exposures. So on the left here would be the equivalent of plain sawing. So that's like if the bark was on that face, that's how that's oriented right there. And on the right we have more like an edge grain, which would be similar to quarter sawn or rift sawn. In fact, it's very much like a rift sawn right there. Pretty much perfect right angle to the growth rings. So let's take a close look at both of those faces after sitting in the sun for a day. Here's the bark side, plain sawn, face grain, and you can see that it's all checked and opened up on those lines right there. Now those lines are where the medullary rays end. We'll see the medullary rays on the other side of the wood, and you can see that those come all the way through the wood, and that's where they daylight out. So those are weak points, and they're prone to opening up like that, and that's a particular problem with this wood. Now I imagine that's probably true in other woods, and there could be two factors at work with the fact that the plain sawn face grain type of exposure tends to crack more. One is that it shrinks more, so it's pulling itself apart, and the other one is that it may be just weaker, and in this case I think that's definitely true. So let's look at the other side here. Now this side appears to have no cracks at all. There's one spot where I could maybe see one opening up right there near that dot on the right. Now look at the medullary rays there. So those are those rays that are coming through and daylighting out. In fact, we could probably see right here on the edge where this one comes right out there that there's going to be, yep, a dark line right there at the edge. Now both ends also show cracking as well. So this particular wood, tan oak, is kind of experimental for me. I do have this one hatchet handle that I made that I've been perfectly happy with. It is a little bit warped, but that's probably the piece of wood that I used more than anything else. And the fact that I carved it mostly green. Yeah, I mean, as far as a full axe handle goes, you know, I've wanted to try it for a long time, and I'm just curious, but I have a feeling it'll make a passable handle even if it doesn't make the best handle. Now, I did get some comments about that and questions. Does oak make good axe handles? I thought you had to use hickory, stuff like that. Oak for axe handles, yes. Oak has been used extensively for tool handles. It's used for axe and other handles in Japan, Japanese white oak. I've seen numerous references to using white oak in North America, in areas where hickory grows. There's a quote from Henry David Thoreau about his farmer neighbor making axe handles. Presumably that's, you know, up where he lived, where hickory also grows. The other reason for seasoning these out is so that they can undergo any kind of shrinking and warping that they're going to undergo. There's a balance between getting something small enough and close enough to shape that it can season without cracking and undergo, like if it wants to warp a little bit and change a little bit, that it's going to undergo some of that before you make it into something. Wood that is reduced in dimension, very small, tends to warp more because the tensions that are in most pieces of wood are free to move because there's less mass and the wood is more flexible. So say if I do this billet, this one warped or twisted a little bit. It's actually quite a bit. So when I go and chop a handle out of that, I make my handle, suddenly it's freed from all this other stiff mass that's holding it in place, and it's more likely to adjust again and warp again, especially if it gets hot, if it gets moist and then dry again and stuff like that. So there's no perfect solution for that, but I think, you know, from my experience, the best solution is getting something down to a reasonable size billet that can move a little bit and change a little bit. Then you carve your piece around that and just hope that it doesn't warp and twist and change. And if it does, you can straighten it. Okay, so there's a real basic version, you know, wood seasoning 101. The only thing we haven't talked about is how to season these, but I think we'll do that at the end of the video when we actually have some green billets. So let's get started.